So friends, today we'll learn about testing of power transformers. Okay, testing of power transformers are very important. Okay, so why we need the testing? So to prove that the design meets the specified job or specified requirements, and to obtain transformer characteristics. So whatever the characteristics, whatever the boundaries within the permissible limit, whether this transformer manufactured or not. So after manufacturing, okay, before manufacturing, we'll design the transformer. After designing that, we'll give the drawings for the manufacturing. After manufacturing, we'll do the testing. Okay, so while doing the testing, what we should know? We should know whether the specified requirements have been met with this designing or not. While doing testing only, we'll find out. Check that the quality requirements have been met and that performance is within the tolerable guaranteed limit or not. That has to be find out. Loading capabilities has to be find out. Dielectric withstand, okay, so any type of impulse, okay, and the separate sources, okay, so such type of difference voltages when comes on the transformer, whether it will be withstand or not, the insulation is properly designed or not, we have to find out by doing the electric strength. Further, operating characteristics has to be find out while doing the testing. What are the type of test we are having? So routine test. Okay, routine test we always continuously whenever you find the time. Okay, periodically you have to do the testing. Okay, and what is the T type test? Type tests are conducted on a transformer which is representative of other transformer. So suppose you understand, right? So the similar transformer already designed. Okay, so in the transformer whatever the test results are coming, with that result will match our newly designed transformer ratings or readings. So that we'll see that whether this transformer within the limit or not, we'll find out by doing the type test. So test special test or test that other than routine and type test, which is agreed between customer and supplier. Suppose any special test recommended by the customer, that has to be done in this special test characteristics. It will be done only once. Okay. Next, routine test. So what are the tests we'll do in the routine test? So routine test is the common test. Okay, before dispatching the transformer from the manufacturing unit and before commissioning of the transformer, or before we will start the erection activities at the site, we will do this routine test. So here the measurement of voltage ratio, vector group, magnetic balance and magnetic current. Measurement of no load loss, core loss, open circuit test, no load test. Okay, all this. Separate source voltage with the sand test also will do. Switching impulse voltage with sand test. Full wave, chopped wave, lightning impulse voltage with sand test, induced over voltage with stand test, measurement of winding resistance, measurement of load loss and impedance, OLTC operation, measurement of insulation resistance, repeat no load loss test, magnetic circuit or isolation test. So friends, we'll go in detail about this all routine test. Okay, before that, you will subscribe the our channel, and you will get the notification for all the thermal power plant related working conditions and testings. Okay, and basic working principles will get the notification. Okay, in type test temperature rise test. Okay, zero sequence impedance measurement, measurement of harmonics in low load current, measurement of sound level, measurement of capacitance in tan delta, and dga analysis. These are the type tests. Okay, we'll do. Next, special test, measurement of power taken by cooling circuit, withstand test on marshalling box, frequency response analysis. Okay, nowadays this frequency response analysis also we have added in the routine test. Okay, because we are doing in the site also. And this test, whatever the first one is, marshalling box. M box means all the protections from the transformer. It will come to the marshalling box, and from marshalling box to it will go to the control room for the SCADA operation or control system, and it will go the gives the command to the relays, and from relays to command goes to circuit breaker for all those activities. Okay. So reference standards, okay. International Electrotechnical Commission (IAC). These are few standards you should remember. Power Transformer General, okay. IAC 60076-2, 60076-3, okay, and 60076-4. These are few guidelines, and based on these guidelines, we have to design the transformer and we have to do the testing. Okay, test sequence. So how the test will be started? Okay, so LV test. So LV side we have to do some testing. Okay, measurement of voltage ratio, voltage group, vector group, magnetic balance, all these things. Measurement of any resistance, insulation resistance. Okay, insulation resistance means Megger will do. Okay, what is the insulation we are having? Okay, it should be in mega ohms always. The measurement of no load loss or core loss or open circuit test or no load current, all these tests will do LV side. Dielectric test. Okay, so whether the dielectric strength of the transformer is okay or not, we'll do all these tests and we'll find out. Test sequence. So temperature, rise test. Zero sequence impedance measurement. Measurement of capacitance tan delta. Repeat no load test loss. Okay. Measurement of harmonics in low load current. Measurement of sound levels. Magnetic circuit or isolation test. Measurement of power taken by cooling circuit with a sand test or marshalling box. Frequency response analysis. Okay. So friends, now we are seeing here the transformer basics. Okay. So how the transformer designed? Yes. So this is the magnetic field. What is the transformer? Transformer is an electrostatic device. Okay. It transformer the voltage from primary circuit to secondary circuit. Okay. Based on the number of terms, the voltage will rise or down. Okay. The power will be remain same from primary side to secondary side. Only voltage will be increased or decreased. If voltage is increased, it is a step up transformer. If voltage is decreased, it is a step down transformer. When you decrease the voltage, proportionately current will increase, right? Because V1 I1 is equal to V2 I2. So when current increase, automatically voltage will be decreased, right? So you have primary voltage, whatever we are giving here, and this is the primary current, and this is the secondary side load, whatever we give. So what is the voltage developed by the transformer action is given by E is equal to 4.44 into F into N into B max into A. Okay, so here you every engineer, electrical engineer knows about these terms. Okay, operating frequency, number of turns. Okay, maximum flux density in the core. Okay, and cross sectional area of the core based on that. Okay, so number of turns is very important. Normal, all these things are same, but number of turns when you increase, your voltage also goes increase. You can see in this diagram here number of turns are less and here number of turns are more. So power transformer is always step up transformer. Okay. So test requirements. So what are the required things or what are the test kits are required? The purpose of the test method, circuit diagram, power requirements, verify the integrity of the test object, verify presence or absence of damage caused by the specific test. Okay, these things you should know before starting the test. Why we are doing the test? Okay, and by which method you are doing the test? So you should draw the circuit diagram before starting the test. So what are the power supply, auxiliary power supply required while doing the test? So all these things must be arranged before starting the test. So in LV side test, we'll do the ratio test, right? So ratio, voltage ratio. Why should we have to do the ratio purpose? to measure voltage ratio between two windings. Okay, primary to secondary. How the what is the whatever the design ratio? Suppose I want 20 kV input side or primary side. I want how many 200 kV suppose secondary side. So primary side one turn is equal one voltage is equal to 20 voltage in the secondary side. So here one turn, here 20 turns. Whether that ratio is matching or not, we'll find out by doing this test. Okay. So test method by voltage ratio meter or by two multimeter method. Anything you can follow. There are the meters available. Directly we can do the ratio test by voltage ratio meter or by using multimeter voltmeter on a primary side and secondary side. Both side you can measure and you can find out. Okay, and this tolerance must be 0.5% plus or minus. Again, magnetic current. Okay, so either HV side or LV side you can do this test. And single phase transformer, single phase power supply is given to HV or LV, and respective winding kept open. Opposite side you have to kept open, and you have to connect one ammeter in series with the winding, and you should know how much current. But secondary side already open, right? So when it is open, so in open condition, which one is taking current? Core itself take current. Okay, magnetizing current. Okay, that will be very minimal. You can measure by using me. Again, polarity test we have to do. Okay, in the polarity test, you can see the circuit diagram. Okay, so here you have to see the voltmeter and you see the lead condition, how the polarity changes, whether it goes negative side or positive side. Next, LV side test verification of vector group. It is very important, and most of people it feels it is little bit difficult to understand how to do or how to verify the vector group. Okay, so but friends, it is very simple to understand the vector group, and it is a routine test in any transformer commissioning. Before commissioning the transformer or before doing the erection also we'll do this test. Okay, so here this is dy1. Okay, so primary side delta, secondary side star, and it is the phase displacement is 1, primary to secondary. Okay, or sometime we'll see that y11 d1 d0 or yd1 yd11 like that. This is the vector diagram. Okay, this is the vector group we can say. Okay, so this vector group is verified or not, we have to find. See here, D means it is a D primary side. Okay, it is delta 1u 1v and 1w. Secondary side star. Okay, okay, secondary side star. So this is the star connection. Okay, 2v u 2v 2w. Okay, and the displacement is 1, so it is on the line only. So what we have to find? See, 1 W 2 V, 1 W 2 V, 1 W to 2 V we have to find out voltage. Again, 1 W to 2 W we have to find out the voltage. 1 U to 2 2W we have to find the voltage, and 1V to 2V we have to find out the voltage. Okay, 1V to 1V 2V. Okay, so all these voltages you have to find out and verify that. See here, 1W to 2V, where is 2V must be, so this is must be equal to 1W 2W, right? So it should be matched. Second thing, 1W 2V, so 1W 2V must be less than 1W 1U. So this, you see this length. Okay, this length is more than this one. Okay, you can verify 1V 2 2V. This voltage must be less than 1V to 2W. 1V to 2W is bigger, right? And this is small. And like that we have to see. Well, we will see one more diagram. So here it was not mentioned, but this diagram vector group is okay. Y, capital Y, small d, and phase displacement 11 degrees. Okay. So first this is one U, one V, one W. This is the primary side star connection, and secondary side delta connection. Okay. Secondary side delta connection, and it is a phase displacement is same on the line, so it's the one. This is the vector diagram, and we have to verify the similar fashion. Okay, 1 u and n, 1 u and n, this voltage is equal to 1 u plus 2 w. Okay, this voltage, and 2 w to neutral, this voltage, sum of this voltage is equal to this. Okay, like that we have to measure. Next, LV test, magnetic balance test. So here simple, applicable for three-phase transformer. Okay, magnetic balance means, suppose if you give the voltage in one phase and you have to measure the voltage in balance two phase, and that voltage must be equal to whatever voltage you are giving here. So your voltage magnetically balanced in that. Okay, it is not going somewhere else, or it is not at all dropping. So you can see like this. Okay, so one U and neutral, you are giving some supply, suppose 200 volts. So here one V or neutral, one W neutral, it should be matched. Suppose here 150 and it can come 50, or here 100 and it can come 100. Like that, it will be tested. Okay. Next, type of transformer losses. So dielectric loss, hysteresis loss in the core, eddy current loss in the core, resistive loss in the winding conductor, increased resistive loss due to eddy current losses in the conductor, extra eddy current losses in the tank structure. Okay. No load losses. So no load losses is hysteresis losses plus eddy current losses plus conductor loss. So magnetic current are passing through the conductor. So these three losses comes from the no load. You are not connected any load, but you are getting some loss. So friends, you go through here. Okay, how the hysteresis losses come, eddy current losses. Okay, here is the formula for the eddy current losses. Okay, and magnetic current balance you have already known by doing the magnetic testing. Okay, next, a separate source. A normal power frequency such as 50 Hz shall be used, and the duration of the test shall be done in 1 minute. Okay, the winding being tested shall have all its parts joined together and connected to the terminal of the testing transformer. All other terminals and parts, including core and tank, shall be connected to ground and to the other terminals of the testing transformer. See here. Okay, so friends, by seeing this circuit, okay, we are, what is this? Separate source we provide for doing the test. Okay, and everybody knows that the Indian standard frequency is 50 hertz. Okay, and we'll do this test for 1 minute, and by that all the parts of the transformers, whatever activities, whatever things are connected to that, all should be connected, and we'll perform the test. So dielectric integrity and its verification. Dielectric tests are intended to verify transformer integrity in the event of voltage stresses which can appear during normal as well as abnormal conditions. Even in normal conditions also, suddenly some load changes. Okay, someone suddenly switch off the 10 megawatt motor. So suddenly load fall will come on the transformer. When load fall will come, voltage will be shoot up. So at that time, whether the insulation will withstand or not, we have to find out. And some abnormal conditions, so line to line fault, short circuit, okay, or lightning effect. In that condition also, whether the transformer will be withstand or not, we have to find out. In general, over voltages are split into three categories. One is over voltage in the power frequency range with a duration in the order of seconds. Okay, which one that one? That is lightning voltage. Okay, just a fraction of seconds. Okay, our voltage impulse will come. Switching over voltages with the duration in the order of fraction of seconds. Okay, Next, lightning over voltage with a duration in the order of microseconds. So in these three categories, we will find okay how dielectric strength will withstand the transformer in the normal or in abnormal conditions. Switching impulse. Temporary operating and non-operating overvoltage are caused by the following. Load rejections. Overvoltage of 1 to 1.4 per unit several seconds. Single phase short circuit. Overvoltage of 1 or 2 to 1.73 per unit depending on the neutral point configuration. Ferro resonance, sawtooth oscillations, Ferranti effect, other resonance oscillations. So these are the conditions where we'll get the switching, okay, and by that we'll get over voltage, and how to withstand those over voltages by the transformer has to be find out by doing the dielectric strength. So switching impulse, okay. So visual front time of the of at least 100 microseconds time, above 90% of the specified amplitude, 200 microseconds total duration of at least 500 microseconds. Will do this test and will give the impulse and will see how it works. Okay. Next, switching impulse. These are the characteristics. Okay, we are giving the impulse and in how short period of time it will be controlled. So lightning effect, same lightning impulse also we have to find out. Okay, how much time it will take, on which basis will move, we have to find out. Okay, next lightning impulse waveform. This is the lightning chopped wave lightning impulse. Induced over voltage withstanding test with the partial discharge. Okay, PD. So partial discharge test. Okay, if any drop or anything, any winding is touched with any other equipment or it is a short circuited, then how the discharges are going on we'll find by doing this test. Okay, so here the C is equal to 120 into rated frequency by test frequency. Okay, at what frequency we are doing test and what are the rated frequency of the transformer into 120. If you do that, you'll find that okay, this discharge voltage, partial discharge PD. Okay, these are the some things about partial discharge activities. Measurement of winding resistance. Okay, so this is the basic routine test. Actually, those are type tests are doing only the manufacturing unit only once. Okay, but type tests are very important for every candidate who are working in the power transformers or who are working for the commissioning of the power transformer. So we'll do the measurement of winding resistance infrequently. So resistance measurement helps to determine the following calculations of the I square R losses, calculation of winding temperature at the end of the temperature rise test as a base for assessing possible damage in the field. Measurement is made with direct current and simultaneous reading current and voltage are taken to minimize errors of observation. The measuring instruments shall have such range as well as give reasonably large depletions. The polarity of the core magnetization shall be kept constant during all resistance reading. Okay, so measurement of winding resistance. Okay, so we'll find the measurement and we'll see how the readings are coming, whether those readings are matching with the factory test or not. We have to compare. So again, a load loss and the impedance test we will do. Next, measurement of load loss and impedance test, how it will be performed you can see here. Okay, we will use one current transformer and here the voltage transformer HV side voltage. Okay, this is the LV side. Okay, it is a wattmeter here and we'll provide the AC source to the transformer and we'll take this reading and we'll find what is the impedance. Okay, this is the measurement of insulation resistance. So objective insulation resistance is the minimum voltage that a transformer should have when tested, and it is the function of the voltage class and the basic impulse level of the winding. The purpose of the measurement of the insulation resistance is to ensure the healthiness of the insulation provided on the winding to withstand the impulse level of the designed voltage class. So here the type of current, so capacitive current, absorption current and leakage current. Measurement mode, so we'll see HV LV to earth, okay, HV to LV and HV LV HV plus earth. Will take 15 seconds, 60 seconds and 600 seconds, means 10 minutes, okay, and we'll find the polarization index. The polarization index must be 1.5 to 2, okay, should be maintained so that it is the transformer insulation is healthy. So temperature rise test or hot run, heat run test. So to establish the top oil temperature rise in steady state condition, to establish the average winding temperature rise at rated current and with the top oil temperature rise. Type of cooling. So these are different: oil, natural, air, natural, oil, natural, air force, oil, natural, air force, oil force, and water force. So water cooled transformers, there are something. So test condition rated power. One winding shorted as like load test. What how we will perform like that only we have to do this test. Okay. So this heat run test, the total loss injection for determination of oil rise. First, the top oil and the average oil temperature rise are established when the transformer is subjected to test a voltage such that the measured active power is equals to the total loss on the transformer. Okay. Capacitance and tan delta test, will conduct this test for the bushings. Okay, so HV bushings are there where 400 kV power supply conducted. For that purpose we'll do this test, and this is very important test. We'll do at factory as well as at the project sites. So we'll do some test on OLTC on load tap changer. Okay, after the tap changer is fully assembled on the transformer, the following tests are performed with exemptions of B 100% of rated auxiliary voltage supply. 8 complete operating cycle with the transformer not energized. 1 complete operating cycle with the transformer not energized. And